Welcome dear students. In this lecture we are going to talk about the most common method used for the manufacture of the sulfuric acid, and that is the contact process which was developed in 19th century. My dear students, the contact process involves different steps. The first one is the formation of sulfur dioxide. Second is the oxidation of sulfur dioxide to sulfur trioxide. Third is the formation of pyrosulfuric acid or oleum. And the fourth one is the formation of the sulfuric acid. Now let us discuss these steps one by one. The SO2 is formed in the sulfur burner. This is a chamber in which pure sulfur is oxidized to SO2, or you can say iron pyrite is combusted and it is converted to the sulfur dioxide and an ore of the iron. So, my dear students, in the sulfur burner, either the pure molten sulfur is burned to SO2 or the iron pyrite is burned to form the sulfur dioxide gas. This sulfur dioxide gas, which is produced in this sulfur burner, that is very impure. It contains different impurities. So it is very important to purify this sulfur dioxide gas before it is introduced into the contact tower where it will be in direct contact with the catalyst. Because the SO2 comes in direct contact with the catalyst, so that is why this is called as the contact process. The purifying unit consists of dust remover. When SO2 moves to the dust remover, then the steam is injected to remove the impurities from the SO2. Then the SO2 is passed through the cooling pipes. These cooling pipes are made up of lead, and the gases, they are cooled down to the 100 degrees Celsius. Then these cooled gases are introduced into the next chamber, which is scrubber, where the spray of water is introduced to remove the water soluble impurities, as SO2 is insoluble in water at high temperature, so it will remain intact. Then these wet gases, they are moved to the drying tower, where drying tower is filled with the coke and the gases are introduced, and concentrated H2SO4 percolates through that coke and it absorbs the moisture out of the gases and the gases are dried. Then there is arsenic purifier or arsenic remover. It is a chamber in which there are different shells in which ferric hydroxide is present, and this ferric hydroxide absorbs the arsenic impurities and the gases are made free of the arsenic. Because the arsenic impurities, they act as poison of the vanadium pentoxide, that is a catalyst in the contact process. So it is very important to remove the arsenic impurities so that the catalyst may not be poisoned. After the purification of gases in all these chambers, then a testing box is there, and in testing box a beam of light is introduced to detect any solid particles present in the gases. If the gases are purified, then they are moved to the next tower, and if the impurities are still present in the gases, then they are moved back to the first chamber of the purifying unit, that is the dust remover. So in this way, only the purified SO2 is allowed to enter into the contact tower where it will be in direct contact with the catalyst, that is vanadium pentoxide. So this contact tower, that is the main part of this whole process, where the SO2 is oxidized to sulfur trioxide gas through a reversible process, as it is reversible in nature. So the dynamic equilibrium will be achieved, and how the optimum yield of the sulfur trioxide can be obtained, it will be described by the Le Chatelier's principle. We want to move this reaction in the right or forward to get the maximum yield of the sulfur trioxide. For that, excess of oxygen can be used, because when the reactants are in excess, then the reaction is favorable in the right direction. Similarly, the high pressure will also move this reaction towards the right, as the reactants, they have greater number of moles and the products, they have lesser number of moles. So if the reactants have greater number of moles and products have lesser number of moles, then increasing pressure shifts the equilibrium towards the right. So the pressure increase, that is the second option to get the optimum yield of the sulfur trioxide. But in this contact process, pressure of 1 to 2 atm is used because of the safety concerns and to make the process economical. Then my dear students, the temperature It is an exothermic process, and in exothermic process, the increase in temperature favors the reaction in the backward direction. But if you will decrease the temperature, that will make the reaction very slow. So optimum temperature is 400 to 500 degrees Celsius. At this temperature, maximum yield of the SO3 is obtained. And we also use the catalyst. Catalyst makes the reaction faster, and that is the vanadium pentoxide in this case. And my dear students, as it is an exothermic process, so the heat is released, and once the reaction is started, then no more heat is required to keep the process going. So this is the main step of this contact process, in which the SO2 is changed to SO3, and Le Chatelier principle helps us to get the optimum yield or maximum yield of the sulfur trioxide. Now, once the sulfur trioxide is obtained, this sulfur trioxide is never directly dissolved in water, because if it is directly dissolved in water, H2SO4 will be produced, but the reaction will be highly exothermic, and that will convert the H2SO4 into the mist. And to collect the mist of the pure H2SO4, that is very difficult. So that is why it is never advisable to dissolve the SO3 directly into water to produce the H2SO4. Rather, in absorption unit, the SO3 is dissolved in 98% H2SO4, and you will get the pyrosulfuric acid, which is also called as the oleum. And then this pyrosulfuric acid is dissolved in water to get the H2SO4 of any concentration. If you will use more water, dilute H2SO4 will be produced. If you will use lesser water, concentrated H2SO4 is produced. And in contact process, usually concentrated H2SO4 is produced. So in this way, the H2SO4 can be produced. The major steps involved the conversion of sulfur to SO2, then SO2 to SO3, and then SO3 to finally H2SO4. This is a flow sheet diagram of the contact process. The flow sheet diagram is a diagram which shows all the steps involved in an industrial process on the sheet of paper in a very easy and comprehensive manner. This is sulfur burner, where molten sulfur is introduced along with air, and the oxygen of this air that will oxidize the molten sulfur to SO2. Then this SO2 will be passed to the dust remover, where steam is injected to remove the impurities. Then it will move through cooling pipes made up of lead, and the gases will be cooled to 100 degrees Celsius. Then it will move to scrubber, where the spray of water is there to remove the water soluble impurities. Then, my dear students, this one is the drying tower, in which concentrated H2SO4 percolates through the bed of the coke to remove the moisture from the wet gases. And finally, these gases then they move to the arsenic purifier, where there are different shelves in which the ferric hydroxide is present, which is an absorber of the arsenic impurities. And once the arsenic impurities are removed, there are no chances of the poisoning of the catalyst. After that, testing box is there, in which the beam of light is introduced to check some solid particles in the gases. Once we are sure that the gases are purified, then they are passed to the catalyst tower, where there will be bed of the V2O5, and SO2 will be in direct contact with V2O5, due to which this process is called as contact process. And SO3 will be produced. That SO3 will be dissolved in 98% H2SO4. You will get oleum, and then oleum will be dissolved in water, and finally you will get the H2SO4 of the required strength. My dear students, H2SO4 is called as the king of chemicals, because the industrial production of the H2SO4, that is the measure of the industrial progress in any country. So a country which produces greater H2SO4, that is having more industrial progress. So the production of H2SO4 is an index to check the industrial progress of any country. That is a very important thing. My dear students, H2SO4 is an excellent dehydrating and oxidizing agent, and these two properties make it very useful. And H2SO4 is used in almost all industries, starting from the simpler to the complex ones. The physical properties are: it has no color, no smell, it is oily in nature, that is why it is also called as the oil of vitriol. The freezing point is 10.5 degrees Celsius, boiling point is 338 degrees Celsius. If it is pure, it is not ionized, and because it is not ionized, it cannot conduct electricity, so it will be non-conductor. But once it is dissolved in water, it is ionized, and then those ions, they will conduct the electricity, and its aqueous solution will become an excellent conductor of the electricity. And if it comes in direct contact with the skin, it will cause the third degree burns. So whenever you are working in the laboratory and H2SO4 comes in direct contact with your skin, it is advisable to wash the skin immediately and remove the H2SO4. Otherwise, it will, because of its dehydrating nature, it will cause severe burns on your skin. So it was all about the contact process to prepare the king of chemicals. I hope so. This lecture will be very useful for you people. In case you find any problem, you can ask in the comment section. Till then, take care.